Hi, in my first video I briefly talk about how to generate Maxwell 2D machine design using the given template, and I already deleted the rotor part because I no longer need it, because I'm gonna develop a rotor structure based on the coordinate myself. First things first, let's create a Maxwell 2D design. And before creating the dynamic rotor, we should define the design variables in order to ease the process. So this is kind of a very structured way of developing things in Ansys. Like if you follow my steps, you should be able to get it done your case too very easily. So if you right click on the new file you created, you can rename by using any name you wish to, and in my case I'm gonna rename it as dynamic rotor. Right, and now let's see how to define the variable. So if you right click on it and select design properties here, you can see now the window is almost empty. It's empty, and you can add variables by clicking on this button. And yeah, let's add some variables based on my design. First I'm going to add a variable called fractions. Unit type is it is without a unit, and I'm going to put a value of 4. And if you scroll to the right, you will see there's evaluated value, which basically for a numeric value it will be same, but if you're going to use some functions here, it will evaluate the value and give a numerical value here. It's very useful when you cross check your equations and whether you get the right answer or not. And let's add some. K here. I'm not going to use any variables, and let's put a value 1. Beta. Now this time I'm going to use okay, let's put 7 then, and it's 1 more, and this time its length, it's in millimeters. These are pre-calculated values based on the reference and the coordinate based design itself. So I think you get the point. You can keep on adding the variables you need to define the coordinates in here, whichever the method you prefer. And now I think you get the point, you know how to add the variables. So I'm gonna hit apply and click apply and hit OK. And for simplicity's sake, I'm gonna open my created, actually I have done it already, so I'm gonna open my case. Says it's open, let's close it. Alright, yes. Okay. Now it's open. It's opened under different category. So if I click design properties here, let me stress this a little bit. Okay, and as you can see, I have defined so many variables in order to define the coordinates properly. So in the previous video I explained briefly how those coordinate the design variables are named and how the theory behind that. So don't worry about these equations. If you do the math, you will come up with the same equations, or if you follow a different method, you can come up with a different answers as well. Like, it's not necessary to follow my steps, but since this is the way that I have done, so I'm just explaining my way of doing things. So one thing to note in here, like if you see here, if you take these functions, the evaluated value is pretty much helpful to uh, uh, determine the correctness of the function that we wrote in here. Like for an example, if you mess up with some unit, you will get a different answer. So it keep that in your mind always. And the other thing is, like, you will have to like introduce some dummy variables sometimes in order to play with the units. So in here you see I had to create a variable called 1, which is a 1 millimeter parameter, but it does some tricks for you. So it's good to know some there are like some things you can play with. So yeah, and after defining those variables, you can simply jump into the rotor design.